So we want to solve the equation tangent of x equals 5 and approximate the solutions which lie on the interval from 0 to 2 pi to 4 decimal places. So if I took the inverse tangent of both sides here, I would have x equal tan inverse of 5. And thinking about when I grab my calculator and I ask it for tan inverse, its range is restricted to this right half from negative pi over 2 to pi over 2, not including the ends. So since this was a positive value, I'm going to get an angle here somewhere in quadrant 1. So I'm going to get the calculator and go ahead and find out what that is. So I make sure I'm in radians. I got inverse tangent of 5. And that's going to be 1.3734. So 1.3734. And then I need to ask myself, where else between 0 and 2 pi would have that same, another angle that would have that same tangent value? It needs to be where angles are positive, and that would be down here in quadrant 3, because x values are negative, y values are negative, and so when you do sine x over cosine x, the negatives cancel and we'll have a positive. So I know the size of this angle right here. So how can I get this angle around here in quadrant 3? Well, it looks like it's pi plus the angle that I have right here, 1.3734. So let's go ahead and compute that, and we will get a second answer for this equation that's on the interval between 0 and 2 pi. So I am just going to do, I already have that angle in my calculator, so I can do plus pi. And that's going to be 4.51. And then as we go to round, that's going to go up to a 5. So 4.515. And that's to 4 decimal places. We can put an O there if we want to show that we did that to 4 decimal places. Now, we're going to answer the same equation, but what if it would have been a negative 5? So as we look at where we're going to get those solutions, the range of angles we're going to get out is going to be from negative pi halves to pi halves, and the tangent is negative. So I know that I will have some angle here in quadrant 4, and it's going to give me a negative angle. It's going to give me, as measured here, a negative angle. And so let's get the calculator and compute that, and that's going to be inverse tangent of negative 5. And indeed it does give me a negative angle, and so that will not be on the interval, but I can get a coterminal angle if I will take that answer and I will add 2 pi. So I'm going to take that negative, and it would have been the negative of this, so negative 1.3734, and I'm going to add 2 pi to it, and I will have my first answer. So plus 2 pi. And that's going to be 4.9097 would make that go up, and then that would make that a 1, so 4.91. So there is my first answer. Now I need to ask myself, where else between 0 and 2 pi would I get the same tangent value at what angle? And it would have to be somewhere over here in quadrant 2, because tangent is also negative in quadrant 2. So looking to see how I could get at this angle in quadrant 2, I can see that this angle and this angle are the same size. So if I did pi minus the 1.3734, I would have the angle I need. So let's go ahead and do that. So I'm going to do pi minus 1.3734, and I get 1.7682. So 1.7682. And again, remember, if you're entering the calculator, this is the smaller one, so you'd put this one in the first answer box and this one in the second.